Today we're going to derive sine x. Now we're not going to do it the geometric way. That way is very complicated. We're going to do it the easy algebraic way. It's really not very difficult when you think about it. When you look at the geometric way, you can get intimidated, but this is not so hard. So the first thing that we're going to do is we're going to write down what we're trying to derive. So we're trying to get sine x prime. We know that it's going to be cosine x, but we want to prove it, right? We want to derive it. So from scratch. So what we're going to do is we're going to plug sine x into the differentiation formula, which is limit as h approaches 0 of f of x plus h over minus f of x over h. Well, the function is a trig function. It's a function of x, so we're gonna make this sine of x plus h, and we're gonna make this sine x. Excuse my desktop notification noise. So now we're going to put all of that over h. All right, well, how do we simplify this, right? It looks confusing. What on earth are you supposed to do next? Well, we're going to use a trig identity to solve this. And the trig identity that we're going to use is sine of a plus b. Now, you might remember it. I'm going to write it down in case you don't. But sine of a plus b is sine a times cosine b plus cosine a times sine b. Not too difficult, and it's going to roll out our numerator. And then we're going to simplify, and then we'll have cosine x in no time. So the first thing that we're going to do here is we're going to plug that in, but with x plus h instead of a plus b. So this is actually going to become sine x prime is going to become limit as h approaches 0, because we haven't taken the limit yet, right? So we're going to keep writing limit as h approaches 0 of sine a, which is going to be sine x, times cosine b, which is going to be cosine h, plus cosine x times sine h. Now, note that we still have that minus sine x from up here. Let's not forget that. And then all of that over h. Now what? Well, now we're going to do two things. But first I'm going to remind you of some differentiation rules that we probably learned in the very beginning when we were first being introduced to differentiation, because they're very important. And I'm going to write them up here. The first one is that the limit as h approaches 0 of sine h over h is 1. And the second one is that the limit as h approaches 0 of cosine h minus 1 over h is 0. And those two are going to help us to prove the derivative of sine. So we're going to try to rearrange it to get these, right? So here's what we're going to do. We are going to factor out sine x right here. We're going to factor out sine x, because right now cosine h and -1 are being multiplied by sine x. So we can factor out these sine x's right here. Okay, so let's do that. Let's factor out the sine x's. It's going to become limit as h approaches 0. Limit as h approaches 0 of sine x. That's supposed to be an S. I'm not sure. I'm not sure if that looks enough like an S to pass for an S. Let's do it again. Sine x times cosine h minus 1. And if we multiplied that out, we would get sine x times cosine h minus sine x, right? So it checks out. And all of that over h. Well, now we have this right here. What do we do here? This is still just, for now, let's just leave it as cosine x times sine h over h. But you can tell we're gonna be able to, when we look at this right here, we can tell we're going to be able to apply this first rule. Okay, so now how do we rewrite this? We rewrite this, I'm going to do it on the right-hand side. Sine of x prime. We rewrite this as sine x over 1 times cosine h minus 1 over h. So sine x over 1 times cosine h minus 1 over h. And that is one chunk that belongs together. Well, then we're going to rewrite this right here as cosine x over 1 times sine h over h. So we're going to end up with cosine x over 1 times sine h over h. Well, now we have exactly what we were looking for. Here we have the second rule. We know that this is going to equal 0. And here we have the first rule, and we know that it's going to equal 1. So that means that we're actually dealing now with sine x times 0 plus cosine x times 1. Well, anything times 0 is 0. So our solution is cosine x. And now we've proved that the derivative of sine is cosine.